Welcome back. So in this session, we are going to discuss the last two methods of finding residues of function of complex variables at pole z equals to a. And in this case, we start by discussing the method of finding the residue at z equals to a, where this pole may be of order 1 or any order, say m. So we say the residue of f of z at z equals to a is given by residue of the function at a is the coefficient of 1 over t, where t is z minus a. So this is the general way of defining residue at a pole z equals to a, where that pole is of any order. It may be of order 1, what is called the simple pole, or order m. So let's give a quick proof for this. So proof. So if f of z has a pole of order m, then by Lorentz theorem, we have f of z is equals to a naught plus a1 into z minus a plus a2 into z minus a squared plus b1 z minus a plus b2 z minus a power 2, and then next term plus b3 z minus a power 3 plus up to bm z minus a power m. So that's what we have. So let's call this one equation 1. So if we put z minus a equals to t, or z equals to a plus t in 1, we get f of a plus t would be given by a naught plus a1 t plus a2 t squared plus b1 over t plus b2 over t squared plus b3 over t cubed plus up to bm over t power m. So call this one equation 2. And you see from definition, then from 2, we have coefficient of B1 as 1 over T. So this B1, which is from definition, the residue of f of z at z equals to A. So hence, residue of the function at A is the same as B1, which is the same as coefficient of B1. Is equals to B1, coefficient of B1. So this means 1 over or simply coefficient of, so this is B1, yeah, that's okay. Coefficient of 1 over T. So that's what I wanted to write here. Coefficient of 1 over T. So residue of f of A is same as residue at z equals to A is coefficient of 1 over T, where T is Z minus A. So that's the proof of that given statement. And lastly, let's give the formula for finding residue at Z equals to infinity. So D, residue of the function f of z at z equals to infinity is given by limit as z approaches infinity of minus z times f of z. So don't forget that formula. Or the residue of f of z at infinity is given by -1 over 2 pi I integral along C of f of z dz. So those are the two ways of finding the residue of f of z at z equals to infinity. So you either use this formula or you use this formula here. So now in the next session and subsequent sessions, we'll be doing examples to illustrate how to find residues of functions by applying all the methods that we have discussed in this session and the previous two sessions. Thank you.